Hey guys, Joe Pye here. Welcome back to the shop. Thank you to all my subscribers. Thank you to all my new subscribers. When I see the subscriptions growing, that's like a big thank you from the people that I help or try to help anyway. So thank you for that and much appreciated. Today's topic is something that I continue to see online. I get offline messages, I get comments. Steady rest. All right, a couple of different kinds of steady rest. We'll get right to it. You have steady rests with wheels, you have steady rests with non-marring brass, bronze tips, whatever. You have 3-point, you have 4-point. Those are about the only ones that I'm familiar with. If there's another kind, and I'm not talking about a follow rest here, I'm talking about a steady rest. It's in place, it's locked down, and you just pray that it's in line with your spindle. So that's what I'm going to address today. And let's talk about when you put a piece in a chuck and you set up a steady rest and you run it. If you have any experience with a steady rest, you watch the track that the wheels, I like roller rests, so that's what we're going to talk about. You watch the track that the wheel is tracking on your part, and eventually you're going to see that track start to get a little bit wider. And when that happens, you know that your part is walking out of the chuck. And that's a kind of a scary thing because you don't know how your features are going to come out. They're going to be concentric. Are they going to be tapered? Are they going to be the size? What's going on? So I'm going to show you why the part starts to walk out of the chuck. It's a thing called micro motion. And in the orthopedic world where I'm from, micro motion is something that is almost undetectable, but it's there, and ultimately it causes big problems downstream. So let's take a look at what's going on. All right, you have the spindle of your machine. Center line. I'll say it's a center line because it's a line between 2 points. Maybe that's the bearings of the machine. Your steady rest, let's say when your steady rest is out here, not on line with that machine, but out here, greatly exaggerated. Of course, it's not going to be 2 inches off. I mean, my God, can't imagine. You have this going on. So here's your chuck jaw. Holding on to that part. Well, greatly exaggerated, of course, when your part is in there and it's sitting forced like this, as this chuck turns, the contact or the pressure value or the pressure distribution of the jaw against the part changes. It reverses as the chuck spins. So if your part is trapped out here in your steady rest and it's spinning this way and the chuck is spinning this way, when this jaw moves around to the back side of the part, this is what you have. So you go from contact in the heel of the jaw to the contact on the tip of the jaw hundreds of times a minute because of how many RPMs the thing is running, and there's your micro motion. It goes, and before you know it, your part starts walking out. So without even realizing it, you are pushing that part out of that machine or pulling it, or however you want to describe it. But anybody that's ever dropped a gauge pin into a nice tight fit hole and can't get it out, you felt that click, 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 click oscillation that will allow that pin to come out of that hole. Same thing's happening right here. So the challenge is to get the center of your steady rest on line with the center of your machine. I've seen a lot of different techniques. A lot of guys rely on indicators, and hopefully they can hang the part out and get the part to run true enough so that they can dial it in while it's running. Sometimes you can get away with that, sometimes you can't. But it sure would be nice to know that in a perfect world, with the machine level, with the head squared to the bed, with the planets lined up and high tide and 72 degrees outside and whatever somebody else is going to add to this equation, you can get that steady rest online with that machine relatively easy. And I was inspired the other day to compare the way I do it to something you can probably find laying around your shop. And if you do have these things laying around your shop, and I'm going to show you what I use. This guy right here will be the inspiration for the solution to your shop problem. And if you know what this is an adjustable stop for the back of a Kurt 675 or 688 vise. And you probably have one of these laying around. If you don't, you should make one because they're a lot of fun to make. Anyway, this piece right here, that's your salvation. I'm going to take you into the shop. I'm going to take you to the inspection area, and I'm going to show you how to set one of these up to help you with steady rest alignment on your lathe. Let's take a walk and check it out. Okay guys, this is the arm from the Kurt stop that I'm going to use. And for this particular operation, I took a piece of 1/4 inch material and I put a flat on it so it's not influenced by the screw too much. And I rounded off the tip so as it spins, I can be assured that I'm going to hit the high spot on it. Now you could do this with a height gauge, an indicator, a V-block stack, a drop indicator, 19 different ways you could set this, but for someone that just has gauge blocks in their shop and some parallels, this is a 3/4 inch diameter bar, so it's 3/8 the center. So whatever stack of gauge blocks you use to set from this surface to here, you want to add in this 3/8 to your calculation to make sure that you have the correct radius set. Since this is a 3/4 diameter and this is a 1/4 diameter rod, I have a 1/4 inch diameter, or excuse me, a 1/4 inch high height gauge or a gauge block underneath it to keep the rod flat. And the stack is quite simple. I have 1 inch and a 125 block here, plus the 375 radius of the bar gives me exactly 1.5 inches from the center line to the top of the stack. Just simply push this in, tighten your screw down, and you know you have an exact 1.5 inch projection from the center of this bar to the tip of your block. Naturally, if you're not turning 3-inch diameter material, set it however you need to set it, and then make an adjustment if you decide to do this again once you turn your journal diameter on your part. Okay guys, for setup purposes, I've got the steady rest on the machine. The machine is clean, and the 5C collet setup is currently in the machine just because I'm changing over from small stock to a larger diameter. Let's take the bar that you just saw me set up. I'm going to stick it in this 3/4 collet. And I'm going to line up the bar with the rollers that are in this rest. And I know a lot of you guys are going, man, that's a great idea. That's why didn't I think of that? Alright, machine's in neutral right now. And what I'm going to do is I'm just going to bring my wheel up. Make sure you have just a little bit of drag on your lock mechanism here so that everything is oriented correctly and you want it to drag. And I'm just going to work this back and forth until my roller starts to show me that it's making contact. See if I can find a marker so we can all see it. All I'm going to do is put a little stripe on here so I can tell for sure that it's moving. There we go, contact. I'm going to do the same thing around the back. Okay, we have motion. Snug it up, check it out. I'm going to come back around to the front wheel and see if it's still kicking, which it is. And at this point, these bottom rollers are set for an exact 3-inch diameter, and the top one, just bring it down and make contact. But just for yucks, I'm going to close this, lock it, it down here and set it. I'm going to put a reference mark on my top wheel, and when I do finally make contact with the actual part, I'm going to verify or just double check where this lines up to check my position. Now you're going to want to maintain pressure on your set screw on your top wheel, because gravity is going to want to pull it down, and you want to stay against the threads as it's coming down. Okay, that's money right there. I'm going to put a little arrow on the top so that it faces the chuck. Snug it. Open it up. There you go. Set for 3-inch. You can do this with any size you want. Actually, if you have a short piece and you have the chuck, you can indicate your short piece and do this exact same thing and then move out. But let's just see how this works out. Give me a couple minutes to change over to my chuck and get a big piece of material, and I'm going to lay that in there and fire it up. Okay guys, I got the 3-jaw chuck in. It is not indicated yet. The steady rest has been moved out into location. The bottom rollers have not been touched. This one is snug. There's an arrow on top facing the chuck. So let's load a piece in here and just see what happens. Now the only reason I have the carriage on this side of the steady rest is so that I can stick an indicator on here and track it to see just how close this setup is going to get me. And we're all going to be surprised together, because I haven't done this on this setup as of right now. For now, I'm just going to go snug just so it turns. I'm not going to make it tight. And this is where we back this guy out. Lock it down. I'm going to loosen this up, and we are sitting right now, the arrow on the top of this knob is sitting at 4 o'clock. With any kind of luck, when I bring it back around to 9 o'clock, it's going to start to turn. And we are right there. We are approximately 20 degrees different. I'm going to have to assume that's because of the backlash in the thread. These are all tight. The rest itself is tight. These ones in the back are a little bit tougher to get to. I'm going to tighten this up. Let's indicate this and see what happens. US General Model 387 indicator base, in case I'm going to get questions on that. It's about 1 million years old. Love it. And just for sake of needle movement, since I am not measuring, right on time there. For sake of indicator movement, since I am not measuring with this indicator, the tip angle really doesn't matter. So I'm just looking for contact. I'm looking to zero out the part. Then we'll turn it on and see what happens. That is really close. Now another technique that I've also seen online, guys working both screws at the same time. I am not a big fan of working both screws at the same time. So when I start indicating a chuck, I'm going to back all 4 of them off. Now naturally you can only do this if you have an adjustable chuck. Okay, all 4 of them are loose. I'm going to look for my low side and I'm going to pull it in. There we go. The chuck body slides nice and easy when they're all loose. Now when you're doing this, when you loosen up all 4, make sure you have sufficient drag on the whole assembly that the weight of the chuck isn't going to move it on the back plate. Snug. Check it. Okay, I like it. Part is tight, part is true. Now inside the steady rest, you are going to have a track left behind by the rollers. It is this track that I was referring to inside that you want to keep your eyes on. I'm just going to open it up so that you can see it. This track right here. You do not want to see that start to get wide, because then you know that the part's pulling out. You also don't want to see your rollers biting into the material and displacing it. So every once in a while, stick your finger in there and feel whether or not your rollers are digging in. You'll know that they're too tight. That is also not good. Now let's put the indicator on the top of this thing and see how it looks. I know the camera's not going to be able to track this indicator, so you're going to have to take my word for the results here. Okay, we are sitting on 0. There's about a 5 thou dip in the center. I'm going to spin it to see if the parts mode or the setup. Check the front. There is almost no indicator movement along the front. I'm not going to lie to you, the indicator did move along the top, which would say that the steady rest is high on this end. That being said, and I'm glad that that happened, it could indicate a level issue with the engine lathe, since the engine lathe has 2 jack screws on the tailstock end and 4 jack screws on the head. The relationship between the head and the bed could be skewed, and the natural centerline projection of the head could get higher or lower as it gets towards the tailstock because of the 4 leveling screws. All in all, I think if you're going to be 2,000s, 3,000s out on a tailstock or a steady rest, I think you're in the ballpark. If you want to make a fine adjustment, which you're probably going to have to do after you turn your journal diameter on there, make it at that time. I do plan to shoot another video on how I am going to check the alignment of my head to my ways. If anyone out there has a way they would like to suggest, a way that they do it, or point me out a video of someone else that's already done it, I would love to see that. But I do plan to shoot one, so by all means. That's all I got for you. Using this little guy right here will get you closer than you could possibly hope to get out here on parts that are naturally not trustworthy to be extended so far, the weight and such. I know that there are some guys out there that do really big material, and this isn't something you just want to leave flopping around to center drill it or whatever. So it's nice to have your steady rest close right from the get-go. Okay, that's all we got. Okay, well naturally if you have a smaller diameter, you can chuck that smaller diameter in a collet or a 3-jaw, 6-jaw, 4-jaw for those of you guys that like to hold round stock in 4 jaws. Get it to run 0, slide your steady rest up against it, and touch off. Slide it back, you're done. Now naturally, the technique that I am a big fan of is you chuck your part, you sit it in the steady rest, you turn a little journal diameter on it, flip it around, you put that journal diameter in the wheels, because round stock isn't always round, and if you hear a thumping, grinding, banging going on your steady rest, it's probably because the high spots are coming around and nastiness is happening. So by all means, technique, this isn't about turning journal diameters and flipping parts around and all that. This is just about how to set that steady rest in line with your lathe. I hope you like what you saw. That stop that I used, if you don't have one of those, make something. Grab a piece of ground stock, grab a piece of stainless, whatever. Make one and set it up the way I showed you. Give it a shot. Try it. If you like it, give me a thumbs up. Give me a comment. Get back to me and let me know how it worked for you. It's a relatively easy solution. And if your machine is properly set and adjusted and leveled, it'll work. So anyway, that's all I got. Until next time, Joe Pye Advanced Innovations, Austin, Texas. I'm out.